Hi, and welcome to TEMEKO. In this video, we will first look at the definition of units and what things one must take into account when making numerical calculations. However, the most important topic of this video is how to perform the analysis procedure. Let's get started. If you recall, in the last lecture, we talked about the basic quantities that we use in mechanics. These quantities were length, time, mass, and force. We also talked about Newton's second law, which can be written as force equals mass times acceleration. At that moment, you may have figured out already that not all basic quantities are independent from each other, but they are indeed related to one another. Some of you may wonder how they are all related. They are related by our familiar Newton's second law. For measuring those quantities, we need units, and because of the relation between quantities, we cannot choose all units arbitrarily. As you can see in the equation, we have mass, for which the unit is the kilogram. We also have an acceleration, which is derived from the two basic quantities, length and time, for which the units are meter and second. These three mentioned units are known as the base units. What about force then? Why doesn't it have a base unit like the rest of the quantities do? Force does not have a base unit, but it has a derived unit because the force is derived from Newton's second law equation by using the base units of mass, length, and time. In Europe and Asia, the international system of units called SI is used. SI is the most widely used system of measurement. One thing to know about the SI system is that the plural form is not used. For example, 2 kg, not 2 kgs. And different calculation rules are applied for the units. The units that we use in mechanics are presented in the SI system table shown. Let us change the subject to numerical calculations for now. What do we need to consider when we are making numerical calculations? For one, the most important thing is to make sure that the calculations must be equal to the units on both sides of the equal sign. Another equally important thing to remember is that there must be at least one more significant digit in the intermediate results than in the final answer. If you start rounding up the intermediate results too soon, this may cause an error in the final answer. The quantity of the error depends on how much the intermediate results are rounded and at which point in the calculations. By taking these things into account, your chances of getting the right result increases. And now to the most important topic in this video. We are going to discuss how to perform the analysis procedure in mechanics. Let us advance step by step on how to perform this procedure. First thing that you should always do is to read the problem carefully. Try to understand the correlation between the task situation and the studied theory. After this, you can begin to solve the problem by drawing necessary diagrams and analyzing the problem data. Then you can continue by applying the suitable equations, solving the equations numerically, and reporting the answer with no more significant numbers than is given in the problem data. The final thing that you should always do is use your common sense, and to think if the solution to the problem makes sense. Hopefully, after watching this video, you know the definition of units and what different things to take into account when you are making numerical calculations. You also know how to perform the analysis procedure correctly for different problems which are linked to mechanics. Thanks for watching and have a nice day.